Yes, there are rules in NFPA 17 National Electrical Code, referred to as NEC, and NFPA 79 Electrical Standard for Industrial Machinery that address the installation of Class 1 circuits and PLC communications in industrial facilities. However, in general, NFPA 79 does not supersede the NEC but rather supplements it. Article 725 Class 1 circuits states that Class 1 circuits are required to be installed in separate raceways or cables from other circuits. Shielding or other means must be provided to prevent interference from other circuits. Article 800 Communication circuits states that communication circuits may be installed in the same raceways or cables as power circuits, provided that separation is maintained. The separation requirements vary depending on the voltage and power of the power circuits. Based on your description, you have identified potential violations of these NEC requirements, such as Class 1 circuits not being separated from other circuits and PLC communication cables not being shielded or otherwise separated from power circuits. NFPA 79 provides additional guidance on the installation of electrical equipment in industrial machinery, including Section 13.4, which addresses the installation of Class 1 circuits, and Section 18.7, which addresses the installation of communication circuits. While NFPA 79 may provide supplemental guidance, it is unlikely to contradict or supersede the NEC requirements. By reviewing NFPA 79, you may gain a better understanding of the industry best practices for electrical installations in industrial machinery. However, it is crucial to ensure compliance with the applicable NEC requirements. To address the potential NEC violations, you should firstly review NFPA 79 for any additional guidance. Secondly, modify your installation practices to adhere to both the NEC and NFPA 79 requirements. And thirdly, consult with an electrical engineer or qualified electrician to verify compliance. Now let's delve a bit deeper into each of these standards. The NEC, or NFPA 70, is a comprehensive set of guidelines for safe electrical installations. It covers a vast range of topics from wiring methods to overcurrent protection, grounding, and equipment installation. It's essentially the Bible for electrical work in most jurisdictions. NFPA 79, on the other hand, is specifically focused on the electrical aspects of industrial machinery. It provides requirements for the design, construction, installation, and operation of electrical equipment on machines. This includes things like control panels, wiring, motor circuits, and safety devices. Think of the NEC as the General Electrical Safety Code, and NFPA 79 as a more specialized code for industrial machinery. They work together, but NFPA 79 provides more specific guidance for machine-related electrical installations. Article 725 of the NEC deals specifically with Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. Class 1 circuits are power-limited circuits that operate at 600 volts or less. These circuits are commonly used for control and signaling in industrial applications such as motor starters, pilot lights, and control relays. The key requirement for Class 1 circuits is that they must be installed in a manner that prevents them from coming into contact with other circuits. This typically means running them in separate raceways or cables. The reason for this separation is to prevent the possibility of a fault in one circuit from affecting another circuit, which could create a safety hazard. Shielding is another important aspect of Class 1 circuit installations. Shielding is used to reduce electrical noise and interference that can disrupt the operation of the circuit. This is particularly important for sensitive control circuits that are susceptible to interference from nearby power circuits or other sources of electrical noise. Article 800 of the NEC covers communication circuits, including telephone, data, and network cables. These circuits are used to transmit information between different devices and systems. One of the key concerns with communication circuits is the potential for interference from power circuits. Power circuits can generate electrical noise that can disrupt the transmission of data over communication cables. To prevent this interference, the NEC requires that communication circuits be separated from power circuits. The specific separation requirements vary depending on the voltage and power of the power circuits. In some cases, it may be necessary to use shielded communication cables or to run the cables in separate raceways. When dealing with potential violations, firstly, regarding Class 1 circuits not being separated, it is crucial to understand the reasoning behind this requirement. Mixing Class 1 circuits with other types of circuits, especially power circuits, can lead to several problems. One potential issue is inductive coupling. Power circuits carrying high currents can induce voltages in nearby Class 1 circuits. This induced voltage can interfere with the operation of the control circuits, causing them to malfunction or operate erratically. Another concern is the risk of a fault in a power circuit propagating to the Class 1 circuit. If a power circuit develops a short circuit or ground fault, the high current can damage the insulation of the Class 1 circuit conductors, potentially causing a fire or electric shock hazard. Physical damage is also a consideration. If Class 1 circuits and power circuits are bundled together without adequate protection, they are more susceptible to physical damage from abrasion, impact, or crushing. This damage can compromise the insulation of the conductors, leading to short circuits, ground faults, or other electrical hazards. Secondly, for PLC communication cables not being shielded or separated, PLCs, or programmable logic controllers, are the brains of many industrial automation systems. They rely on reliable communication to control and monitor various processes. If the communication cables are not properly shielded or separated from noise sources, the data transmitted between the PLC and other devices can become corrupted or lost. This can lead to unpredictable or erratic machine behavior, potentially causing damage to equipment or injury to personnel. Electrical noise can be generated by various sources, such as motors, drives, transformers, and welding equipment. This noise can be coupled into the communication cables through electromagnetic interference or radio frequency interference. Shielding the communication cables provides a barrier that blocks or attenuates this noise, preventing it from interfering with the data signals. Separation of communication cables from noise sources is also important. This can be achieved by running the cables in separate raceways or conduits, or by maintaining a minimum distance between the cables and the noise sources. Regarding NFPA 79 supplemental guidance, you will find specific requirements for the installation of electrical equipment on industrial machinery. These requirements are intended to ensure that the equipment is installed in a safe and reliable manner. Section 13.4 of NFPA 79 provides detailed guidelines for the installation of Class 1 circuits on industrial machinery. It covers topics such as conductor sizing, overcurrent protection, wiring methods, and grounding. It also addresses the separation of Class 1 circuits from other circuits and the use of shielding to reduce electrical noise. Section 18.7 of NFPA 79 provides similar guidance for the installation of communication circuits on industrial machinery. It covers topics such as cable selection, routing, termination, and grounding. It also addresses the separation of communication circuits from power circuits and the use of surge protection devices to protect against voltage transients. Regarding NFPA 79 not contradicting the NEC, it's important to recognize that NFPA 79 is not intended to replace or override the NEC. Instead, it supplements the NEC by providing additional requirements that are specific to industrial machinery. In most cases, if there is a conflict between the NEC and NFPA 79, the NEC will take precedence. However, NFPA 79 may provide more stringent requirements in certain areas, such as the separation of circuits or the use of safety devices. Regarding industry best practices, NFPA 79 represents a consensus of industry experts on the best practices for electrical installations on industrial machinery. By following these best practices, you can improve the safety, reliability, and performance of your equipment. This can reduce the risk of electrical hazards, minimize downtime, and improve the overall efficiency of your operations. Always comply with the NEC. Compliance with the NEC is essential for ensuring the safety of electrical installations. Failure to comply with the NEC can result in fines, penalties, and even legal liability. It can also create a dangerous work environment for employees and increase the risk of electrical accidents. Regarding the recommendations, it's important to take a proactive approach to address the potential NEC violations that you have identified. This may involve modifying your installation practices, upgrading your equipment, or consulting with an electrical engineer or qualified electrician. A thorough review of NFPA 79 is a critical step in ensuring compliance with the applicable requirements. This review should cover all aspects of the electrical installation, from conductor sizing to overcurrent protection to grounding. You should also pay close attention to the requirements for the separation of circuits and the use of shielding. Modifying installation practices is often necessary to comply with both the NEC and NFPA 79 requirements. This may involve changing the way that you route cables, install raceways, or terminate conductors. It may also involve using different types of equipment or materials. For example, you may need to switch to shielded cables or use separate raceways for Class 1 circuits and power circuits. Consulting with an electrical engineer or qualified electrician can provide valuable assistance in verifying compliance with the NEC and NFPA 79. These professionals have the knowledge and experience to identify potential violations and recommend solutions. They can also help you to develop and implement a comprehensive electrical safety program. Let's consider some specific examples of how NFPA 79 supplements the NEC. One example is the use of disconnect switches. The NEC requires disconnect switches for certain types of equipment, but NFPA 79 provides more specific requirements for the location and type of disconnect switches used on industrial machinery. NFPA 79 also requires that disconnect switches be clearly labeled to indicate the equipment they control. Another example is the use of emergency stop devices. The NEC requires emergency stop devices for certain types of equipment, but NFPA 79 provides more specific requirements for the design and installation of these devices. NFPA 79 also requires that emergency stop devices be easily accessible and clearly identified. Consider the practical implications of these standards. Think about a situation where you have a control panel that houses both Class 1 circuits and power circuits. According to the NEC and NFPA 79, you would need to ensure that the Class 1 circuits are physically separated from the power circuits. This could be achieved by using separate wiring ducts or by installing a barrier between the two types of circuits. You would also need to ensure that the Class 1 circuits are properly shielded to prevent electrical noise from interfering with their operation. This could be achieved by using shielded cables or by installing a metal enclosure around the Class 1 circuits. Another practical consideration is the selection of appropriate wiring methods. The NEC and NFPA 79 specify different types of wiring methods that are suitable for different applications. For example, you might use rigid metal conduit for circuits that are exposed to physical damage, or you might use flexible metal conduit for circuits that need to be moved or adjusted. The NEC contains tables, such as Table 310.15b16, that specify the allowable ampacities of insulated conductors. These tables are used to determine the appropriate size of conductors for different applications. NFPA 79 also provides guidance on conductor sizing, but it is important to ensure that you comply with the NEC requirements. Overcurrent protection is another critical aspect of electrical safety. The NEC requires that all circuits be protected by overcurrent devices, such as fuses or circuit breakers. These devices are designed to interrupt the flow of current in the event of a short circuit or overload. NFPA 79 also provides guidance on overcurrent protection, but it is important to ensure that you comply with the NEC requirements. Grounding is another essential aspect of electrical safety. The NEC requires that all electrical equipment be properly grounded to prevent electric shock hazards. Grounding provides a low impedance path for fault current to flow back to the source, which causes the overcurrent device to trip and to energize the circuit. NFPA 79 also provides guidance on grounding, but it is important to ensure that you comply with the NEC requirements. Regular inspection and testing of electrical installations is essential for maintaining electrical safety. The NEC and NFPA 79 require that electrical installations be inspected and tested on a regular basis to identify potential hazards. These inspections should be performed by qualified personnel who are familiar with the NEC and NFPA 79 requirements. When performing electrical work on industrial machinery, it is essential to follow lockout-tagout procedures. Lockout-tagout is a safety procedure that is used to prevent accidental energization of equipment during maintenance or repair. This procedure involves disconnecting the equipment from its power source and attaching a lock and tag to the disconnect switch to prevent it from being turned on accidentally. Working with electrical equipment can be dangerous, so it is essential to take the necessary precautions to protect yourself from electric shock. This includes wearing appropriate personal protective equipment, such as insulated gloves and safety glasses, and using properly insulated tools. You should also be aware of the potential hazards of working with electricity and take steps to avoid them. Understanding concepts like fault current, arc flash, and overvoltage is essential for electrical safety. Fault current is the current that flows through a circuit during a short circuit or ground fault. Arc flash is a dangerous electrical explosion that can occur when there is a short circuit or ground fault. Overvoltage is a temporary increase in voltage that can damage electrical equipment. In summary, while NFPA 79 provides valuable supplemental guidance for electrical installations on industrial machinery, it is crucial to remember that the NEC remains the primary code for electrical safety. Always prioritize compliance with the NEC and consult with qualified professionals to ensure the safety and reliability of your electrical systems. Remember to stay updated on the latest versions of the NEC and NFPA 79 as they are updated periodically to reflect changes in technology and best practices. Continuous learning and professional development are essential for staying current in the field of electrical safety.